To check for responses, firstly, log into your JustAnswer account on the JustAnswer website. Secondly, click on My Questions from the main menu. Thirdly, find the question you posted and click on it. To check for responses via email, firstly, check your email inbox for a response from a JustAnswer expert. Secondly, the email will have the subject line "Expert response to your question" title and will contain a link to your question and the expert's response. If you have previously opted out of email notifications, you may not receive an email alert when someone responds to your question. You can manage your email notifications from your JustAnswer account settings. Understanding electrical codes is essential for safety and compliance. These codes, often based on the National Electrical Code or NEC, provide guidelines for electrical installations in residential, commercial, and industrial buildings. When working with electricity, it's crucial to adhere to these codes to prevent hazards such as electrical shocks, fires, and equipment damage. The NEC is a comprehensive document that covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It's updated every 3 years to reflect changes in technology and best practices. Navigating the NEC can be challenging, especially for those who are not electrical experts. That's why resources like JustAnswer can be valuable for getting quick answers to specific code-related questions. When you have a question about electrical codes, it's helpful to provide as much detail as possible. This includes the specific section of the NEC that you're concerned about, the type of electrical system you're working with, and any relevant details about the installation. The more information you provide, the better the expert will be able to understand your question and provide an accurate and helpful response. Overcurrent protection is a critical aspect of electrical safety. Overcurrent devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow. When an overcurrent occurs, the device will trip or blow, interrupting the flow of electricity and preventing damage to the circuit and equipment. It's important to select the correct size of a current device for the circuit. The size of the device should be based on the ampacity of the conductors in the circuit. Ampacity is the maximum amount of current that a conductor can safely carry without overheating. The NEC provides tables that specify the ampacity of different types of conductors based on their size and insulation type. Grounding is another essential safety measure in electrical systems. Grounding provides a low impedance path for fault current to flow back to the source. This helps to quickly trip over current devices and prevent electrical shock hazards. There are 2 main types of grounding systems: equipment grounding and system grounding. Equipment grounding connects the non-current carrying metal parts of electrical equipment to ground. System grounding connects the neutral conductor of the electrical system to ground. Proper grounding is essential for ensuring the safety of people and equipment. Wiring methods are also covered extensively in the NEC. The NEC specifies the types of wiring methods that are permitted for different applications. Wiring methods include conduit, cable, and raceway systems. Each wiring method has its own advantages and disadvantages in terms of cost, installation, and protection. It's important to select the appropriate wiring method for the specific application. For example, conduit is often used in commercial and industrial buildings because it provides a high level of protection for the conductors. Cable is often used in residential buildings because it's easier to install. When working with electrical systems, it's important to follow all applicable codes and regulations. Failure to do so can result in serious injury or property damage. If you're not sure about something, it's always best to consult with a qualified electrician. Here is an example scenario concerning wire ampacity. Imagine you're installing a new 20-amp circuit in your home to power several outlets. You need to determine the appropriate size of wire to use for the circuit. According to NEC Table 310.15b16, a 12 American wire gauge copper wire with type THHN insulation has an ampacity of 30 amps. This would be suitable for a 20-amp circuit. However, you also need to consider voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or not operate properly. The NEC recommends limiting voltage drop to 3% for branch circuits. To calculate voltage drop, you need to know the length of the circuit, the current flowing through the circuit, and the resistance of the wire. There are online voltage drop calculators that can help you with this calculation. If the voltage drop is excessive, you may need to increase the size of the wire to reduce the resistance. Another important consideration is the type of load that the circuit will be serving. Some loads, such as motors and transformers, draw a large amount of current when they start up. This inrush current can trip circuit breakers if the circuit is not properly sized. The NEC provides rules for sizing circuits that serve these types of loads. For example, the NEC requires that motor circuits be sized at 125% of the motor's full load current rating. This helps to prevent nuisance tripping of the circuit breaker. When installing electrical equipment, it's important to follow the manufacturer's instructions. The manufacturer's instructions will provide information on how to properly install and wire the equipment. Failure to follow the manufacturer's instructions can void the warranty and create a safety hazard. It's also important to use the correct tools for the job. Using the wrong tools can damage the equipment or injure yourself. For example, when stripping wires, it's important to use a wire stripper that is designed for the size of wire you're working with. Using a knife or other sharp object to strip wires can damage the insulation and create a short circuit hazard. When making connections, it's important to use the correct type of connector. There are different types of connectors for different applications. For example, wire nuts are commonly used to connect wires in junction boxes. Crimp connectors are often used to connect wires to terminals. It's important to make sure that the connections are tight and secure. Loose connections can cause overheating and create a fire hazard. When working with electricity, it's always important to take precautions to protect yourself from electrical shock. Always turn off the power to the circuit before working on it. Use a voltage tester to verify that the power is off. Wear insulated gloves and safety glasses. Never work on electrical equipment when you're wet or standing in water. Electrical work can be dangerous, so it's important to be careful and follow all safety precautions. If you're not comfortable working with electricity, it's best to hire a qualified electrician. An electrician has the training and experience to safely and properly install and repair electrical systems. The NEC also covers specific requirements for different types of occupancies such as residential, commercial, and industrial buildings. These requirements address the unique electrical needs of each type of occupancy. For example, residential buildings have specific requirements for the number and location of outlets and lighting fixtures. Commercial buildings have specific requirements for emergency lighting and fire alarm systems. Industrial buildings have specific requirements for hazardous locations and motor control centers. The NEC also covers specific requirements for special equipment such as swimming pools, spas, and electric signs. These requirements address the unique electrical hazards associated with each type of equipment. For example, swimming pools have specific requirements for bonding and grounding to prevent electrical shock hazards. Electric signs have specific requirements for overcurrent protection and wiring methods to prevent fires. When working with electrical systems, it's important to stay up to date in the latest codes and regulations. The NEC is updated every 3 years, so it's important to make sure that you're using the latest edition. You can purchase a copy of the NEC from the National Fire Protection Association or NFPA. You can also find information about the NEC online. There are many websites and forums that provide information about electrical codes and regulations. These resources can be helpful for answering your questions and staying informed about the latest changes. In addition to the NEC, there may be local electrical codes that you need to follow. Local electrical codes are often based on the NEC, but they may have additional requirements that are specific to your area. It's important to check with your local building department to find out what electrical codes apply to your project. Electrical inspections are typically required for new construction and electrical renovations. An electrical inspector will review your work to make sure that it complies with the applicable codes and regulations. Electrical inspections help to ensure the safety of people and property. Before starting any electrical work, it's important to obtain the necessary permits. Permits are required for most electrical projects, including new wiring, panel upgrades, and service changes. Permits help to ensure that the work is done safely and in compliance with the applicable codes and regulations. To obtain a permit, you'll typically need to submit a set of plans to your local building department. The plan should show the scope of the work and the location of all electrical equipment. The building department will review the plans and issue a permit if they meet the requirements. During the electrical inspection, the inspector will check the wiring, grounding, overcurrent protection, and other aspects of the electrical system. If the inspector finds any violations, you'll need to correct them before the inspection can be approved. Once the inspection is approved, you can energize the electrical system and begin using it. It's important to keep a copy of the inspection report for your records. The inspection report can be helpful if you ever need to make repairs or modifications to the electrical system in the future. When working with electrical systems, it's important to remember that safety is always the top priority. Always follow all applicable codes and regulations, and take precautions to protect yourself from electrical shock. If you're not sure about something, it's best to consult with a qualified electrician.